First of all, I welcome you all. I am Beeresh MP.
I'm Kaveri T.
I'm Nuthan S.
I'm Gowthami A N.
We are presenting on the topic called face forgery detection under the guidance of Professor Honnaraju B. Here we begin. Now, this is the index or the list of content that we have followed. Next is an introduction. First question arises, what is image forgery? So basically, tampering an image on making any changes onto an authenticate image is called image forgery. That image is called forged image. As we all know that some of the people in the world are misusing these techniques called manipulating the face of an image by using different applications like Photoshop, FaceApp, and so on. And also, it is very difficult to differentiate the two images. To avoid this kind of misuse, and here is our project all about to tell that image provided is a real or fake. In technical terms, authenticate or tampered. In the next slide, I will be explaining how these manipulations are going on. As we are seeing that here is a three different varieties of image, that is attribute manipulation, identity swap, and expression swap. Coming to an attribute manipulation. These manipulations also known as face editing or face retouching. It consists of modifying some attributes of a face such as color of the hair, the skin, the age, the gender, and so on. As I have told earlier, there is an application called FaceApp. It is the best example for attribute manipulation. Next is identity swap. This manipulation consists of replacing of a face of a person in an image with the face of another person. Next is an expression swap. This manipulation, also known as face reenactment, consists of modifying the facial expression of a person. To detect this kind of manipulation, we are come up with this topic, and this is a brief introduction of our topic. And here is Nuthan will going to explain about the motivation and problem source.
Let us look on to motivation and problem source. In today's developments in digital technology, images are simple to manipulate and alter due to the accessibility of numerous powerful editing software tools like Adobe Photoshop, GIMP, Corel Paint Shop, and they ended up with a threat for authenticity of digital images. It is conceivable to add or remove important features from an image without leaving any undeniable proof of image forger, which results in a high number of image forgeries. Novice tampering of an image is becoming challenging day by day. It is being used for hiding fact evidences, so not only lose the reliability of an image, but also being used as a tool for doing certain unlawful activities. At present, people are facing image forgeries in many real-time applications such as code, data financial, legal evidence, medical reports, high-value assets, even in scientific literature. This motivates to design a novel framework for detection of image forgery and to distinguish the forgery image and authenticate image. In this research, image processing techniques are implemented to achieve an efficient result for detection of forgery image. Here is Gowthami is going to explain about existing system and proposed work.
Let us look on to existing system. There are two kinds of image processing tampering detection techniques. First is active forgery detection and passive forgery detection. Let us look on to active forgery detection. It means that watermarking and signature are the main techniques of active forgery detection. A watermark or a signature is embedded in the original image and it can be extracted by some algorithms. When the image is tampered, the special information cannot be extracted. Next, coming to an passive forgery detection, it means that technique lies on the image processing technology to detect the forgery. No matter how a digital photo has been changed, I leave footprints. For example, altering the statistic properties image in the numerical pattern that underlies the photo. Copy forgery is a specific type of image tampering which is usually used to hide a specific object of the original image. When an object is removed from a photo, often another portion of a same picture is copied and inserted to fill the gap, which is not in a natural image. By using these two approaches, it will be very costly and will not predict that much accurately. Hence, to overcome this drawback, we came with an approach to detect face of a person accurately within less cost. Next, let us look on to proposed work. Two-stage analysis of a LBPH algorithm to extract features at the frame. LBPH means local binary pattern histogram algorithm. It is a simple solution on face recognition problem which can be recognized both front and side face, and it will convert into intermediate image that describes the original image in a better way, highlighting the facial characteristics. To evaluate a proposed method of a collection of images are used, and half of the fake image are from multiple image hosting. Here and here is a Kaveri will going to explain about objectives and initial plan.
Let us look on to objectives. Here, our main objective is to detect whether the suspect image is forged or not. So, firstly, we will upload an image file which is need to be tested, and it will be of type JPG, PNG, GIF, or etc. Next, we apply LBPH algorithm, that is local binary pattern histogram. Here, LBP is combined with histogram of orient gradient descriptor as it improves detection performance. LBP labels the pixels of an image by thresholding the neighborhood of each pixels and consider result as a binary number. Using LBP combined with the histogram, we can represent face images with a simplest data vector. And central value of this transformation matrix will be used as a threshold. As we all know, computer will only understand the binary language, so we have a trained data set contains a facial landmark data set. And this trained data set will be converted into a binary pattern of transformation matrix like zeros and ones. And the color will be in a RGB format. This matrix contains information about the facial characteristics like length and width of right eye and the left eye, and length and height of a nose, width of a lips, and other characteristics. Then we do a frame extraction of uploaded image where we can extract up to 35 frames per second, but it will be very complex to us. So we'll be considering only 4 to 5 frames. Then each of the frames gets converted to a binary transformation matrix form. Then we'll be comparing it with the trained data set so as to check whether the both pattern will match or not. It will accurate up to 95% with a greater detection performance. Then we conclude that if pixels mismatches, the suspect image is forged. Otherwise, it's not forged. So next, we'll move on to the initial plans. In designing part, in our designing part, firstly, the input will be an image file. We will be using LBPH algorithm to generate a LBP code for each pixels, and occurrence of each possible pattern in image is kept up, and this forms a representation of texture of image. This vector forms an effective representation of face and used to measure similarities between images, and the extracted frames are then converted into a transformation matrix form in a binary format. And further, we do a comparison method. Here is a Nuthan is going to explain about the SRS.
Let us look on to SRS, that is System Requirement Specification. For our project, there are system requirements which we need. Like for operating system, we need Windows 7 and above. For coding, we are implementing by using Python with OpenCV, and version of Python should be 3.7 and above. Here is Kavya is going to explain about implementation and testing.
Let's move on to the implementation and testing. So here we implement our project using a specified system requirement as mentioned by Nuthan. Using a binary representation of matrix, we do compare of frame patterns for testing to know whether the suspect image has been forged or not. This is all about our initial plans.
By this, we are concluding our presentation that to avoid misuse of the manipulation of a face of an image, so we have come up with this technology. Thank you.
Victor, any questions?
Honnaraju,
Honnaraju sir, I know the students are in good hands. Okay, first thing. But you see, their objectives look like methodology, right? That's the only observation which I found there. Okay. And in between, like, they explained your objectives, obviously, but again, that looks like a methodology, no, sir?
Yeah,
Yeah,
yes.
that's
Yeah.
it. That's it from my side. Yeah.
Go back to the objective slide.
Okay, ma'am.
In the objectives, first you have said apply algorithm and then you have said frame extraction, correct?
Yes, ma'am.
So it almost looks like you're applying the algorithm for frame extraction.
ಮ್ಯಾಮ್ ಫಸ್ಟ್ ಏನು ಮಾಡ್ತೀವಿ ಅಂದರೆ ಇಲ್ಲಿ ಫಸ್ಟು ಇಮೇಜ್ ಸಸ್ಪೆಕ್ಟ್ ಇರುತ್ತಲ್ಲ ಮ್ಯಾಮ್ ಅದು ನಾವು ರಿಯಲ್ ಆರ್ ಫೇಕ್ ಅಂತ ಚೆಕ್ ಮಾಡ್ಬೇಕಂತ ನಮಗೆ ಕನ್ಫ್ಯೂಷನ್ ಇರುತ್ತಲ್ಲ ಮ್ಯಾಮ್ ಅದನ್ನ ಅಪ್ಲೋಡ್ ಮಾಡ್ತೀವಿ ಮ್ಯಾಮ್ ಫೈಲ್ನ.
ಕರೆಕ್ಟ್, ಓಕೆ.
ಅದಾದ್ಮೇಲೆ ಬೈ ಯೂಸಿಂಗ್ LBBH ಆಲ್ಗೋರಿಥಮ್ ಮೀನ್ಸ್ ಲೋಕಲ್ ಬೈನರಿ ಪ್ಯಾಟರ್ನ್ ಹಿಸ್ಟೋಗ್ರಾಮ್ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಅದು ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ ಮ್ಯಾಮ್. ಅದು ಬೈನರಿ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಶನ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ ಮ್ಯಾಮ್. ಅದು ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಶನ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಹೆಂಗಿರುತ್ತೆ ಅಂದ್ರೆ ಜೀರೋಸ್ ಮತ್ತೆ ಒಂದ್ಸಲಿ ಅದು ರೆಪ್ರೆಸೆಂಟೇಷನ್ ಆಗಿರುತ್ತೆ ಮ್ಯಾಮ್. ಅದಾದ ತಕ್ಷಣ ಒಂದು ಟ್ರೈನ್ ಡಾಟಾ ಸೆಟ್ ಅಂತ .xml ಫೈಲ್ ಅಲ್ಲಿ ನಾವು ಟ್ರೈನ್ ಡಾಟಾ ಸೆಟ್ಸ್ ಅಂದ್ರೆ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನಮ್ದು 10 ಇಮೇಜಸ್ ನಾವು ಬಿಗಿನಿಂಗ್ ಓನ್ಲಿ ಅಪ್ಲೋಡ್ ಮಾಡಿರ್ತೀವಿ ಮ್ಯಾಮ್. ಅದು
ಬೀರೇಶ್
ಹೇಳಿ ಸರ್.
ಹೇಳಿ ಸರ್. ಏನು ಬ್ಯಾಕ್ ಗ್ರೌಂಡ್ ಡಿಸ್ಟರ್ಬೆನ್ಸ್ ಸಿಕ್ಕಾಬಟ್ಟೆ
ಸರ್ ಎಕೋ ಆಗ್ತಿದೆ ಸರ್ ಅಷ್ಟೇ ಸರ್.
ಇಲ್ಲೋ ಹಿಂದೆ ಯಾರೋ ಮಾತಾಡ್ತಾ ಇದ್ದಾರೆ
ಸರ್. ಅಲ್ಲಿ ಸರ್ ಇಲ್ಲ ಇವಾಗ ಏನಿಲ್ಲ ಸರ್.
ಸರಿ ಸರ್, ಓಕೆ. ಹೇಳಿ, ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡು
ಸರ್. ಕಾವ್ಯ ಮ್ಯಾಮ್ ಕೇಳಿಸ್ಕೊತಿಲ್ಲ ಅನ್ಕೋತೀನಿ.
ಹೇಳಿ
ಹೇಳಿ.
ಮ್ಯೂಟ್ ಮಾಡಿದ್ದೀನಿ
ಓಕೆ ಓಕೆ.
ಸೊ ದಟ್ ಬ್ಯಾಕ್ ಗ್ರೌಂಡ್ ಡಿಸ್ಟರ್ಬ್ ಆಗಬಾರ್ದು ಅಂತ ನೀವು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿ.
ಓಕೆ
ನಾನು ಕೇಳಿಸ್ಕೊತಾ ಇದ್ದೀನಿ.
ಮ್ಯಾಮ್ ಟ್ರೈನ್ ಡಾಟಾ ಸೆಟ್ ಅಲ್ಲಿ ಏನಿರುತ್ತೆ ಅಂದ್ರೆ ಒರಿಜಿನಲ್ ಇಮೇಜಸ್ಗಳನ್ನ ನಾವು ಆಲ್ರೆಡಿ ನಾವು ಸ್ಟೋರ್ ಮಾಡಿ ಇಟ್ಕೊಂಡಿರ್ತೀವಿ ಮ್ಯಾಮ್. ಜಸ್ಟ್ ನಾವು ಅಪ್ಲೋಡ್ ಮಾಡ್ತೀವಲ್ಲ ಮ್ಯಾಮ್ ಫೈಲು, ಅದು ಅದ್ರ ಜೊತೆ ಕಂಪೇರ್ ಮಾಡುತ್ತೆ ಮ್ಯಾಮ್. ಅದು ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಕಂಪೇರ್ ಮಾಡ್ಕೊಂಡು ಅದು ಡಿಫ್ರೆಂಟ್ ಕೈಂಡ್ಸ್ ಆಫ್ ಫ್ರೇಮ್ಸ್ ಆಗಿ ಡಿವೈಡ್ ಆಗುತ್ತೆ ಮ್ಯಾಮ್. ಪರ್ ಸೆಕೆಂಡ್ಗೆ ನಾವು 35 ಫ್ರೇಮ್ಸ್ ಪರ್ ಸೆಕೆಂಡ್ ಆಗಿ ಎಕ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡ್ಬೋದು ಮ್ಯಾಮ್. ಬಟ್ ಆದ್ರೆ ತುಂಬಾ ಕಾಂಪ್ಲಿಕೇಟ್ ಆಗೋದ್ರಿಂದ ನಾವು ಅರೌಂಡ್ 4 to 5 ಫ್ರೇಮ್ಸ್ ಆಗಿ ಡಿವೈಡ್ ಮಾಡ್ಕೋತೀವಿ ಮ್ಯಾಮ್. ಜಸ್ಟ್ ಅದ್ರಲ್ಲೇನೆ ನಾವು ಕಂಪೇರ್ ಮಾಡ್ತಾ ಹೋಗ್ತಿರ್ತೀವಿ ಮ್ಯಾಮ್. ಏನಂದ್ರೆ ಲೆಫ್ಟ್ ಐ ಮತ್ತೆ ವಿಡ್ತು ಮತ್ತೆ ಹೈಟು, ನೋಸ್ ವಿಡ್ತು ಮತ್ತೆ ಹೈಟು, ರೈಟ್ ಐ ವಿಡ್ತು ಮತ್ತೆ ಹೈಟು, ದ ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದ ನೋಸ್ ಅಂಡ್ ಐ ಜೊತೆ ಕಂಪೇರ್ ಮಾಡ್ಕೊಂಡು ಲಾಸ್ಟ್ ಅಲ್ಲಿ ಚೆಕ್ ಮಾಡ್ತೀವಿ ಮ್ಯಾಮ್. ಅದು ಟ್ರೈನ್ ಡಾಟಾ ಸೆಟ್ ಅಲ್ಲಿ ಇರುತ್ತಲ್ಲ ಮ್ಯಾಮ್ ಒಂದು ಇಮೇಜು, ಅದು ಮತ್ತೆ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಶನ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಯಾವುದು ಈಕ್ವಲ್ ಆಗುತ್ತೆ. ಜಸ್ಟ್ ವಿ ಆರ್ ಪ್ರಿಡಿಕ್ಟಿಂಗ್ ಎಟ್ ಲಾಸ್ಟ್ ದಟ್ ದ ಪಿಕ್ಸೆಲ್ ಸೈಜ್ ಮಿಸ್ಮ್ಯಾಚ್ ಆದ್ರೆ ದ ಇಮೇಜ್ ಇಸ್ ನಾಟ್ ಮ್ಯಾಚಿಂಗ್ ಅಂತ ಹೇಳ್ತೀವಿ ಮ್ಯಾಮ್. ಅಕಸ್ಮಾತ್ ಮ್ಯಾಚ್ ಆದ್ರೆ ಅದು ದ ಔಟ್ಪುಟ್ ಇಸ್ ರಿಯಲ್ ಅಂತ ಹೇಳ್ತೀವಿ ಮ್ಯಾಮ್.
Okay, fine. Okay, no more questions.
Thank you,
I
ma'am.
wanted some clarity about that.
ಬೀರೇಶ್
ಸರ್ ಹೇಳಿ ಸರ್.
ಹಲೋ,
ಹೇಳಿ ಸರ್.
ಎಂಡ್ ಮಾಡಿ ಮೀಟಿಂಗ್.
ಓಕೆ,
ಎಂಡ್ ಮಾಡಿ ಮೀಟಿಂಗ್.
ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು.
Guys, any questions?